Hello guys, so in this video we are going to say this particular problem, group of strings. Okay, so what this problem says is you are given a zero indexed array of words. Each string consists of lowercase English letters only and no letter occurs more than once in a string of words. Okay, so basically it is saying is you will be given a string of words, like an array of strings, and each of the letters present in each of these strings will be unique, like they won't be repeated. Okay. Now the conditions here is two strings are S1 and S2 are said to be connected if the set of letters of S2 can be obtained from the set of letters of S1. So basically it is saying that if you have two strings S1 and S2, they are connected when we perform some action on this S1. These actions are given here, all these three, and on performing any one of this action only once, then you obtain this S2. Okay, so let's see what are those options. You can either add a letter in the set of S1. Okay, and like by the definition itself you can see we don't have to add the letter that is already there. Okay, so we have to add a particular letter S1. We can either delete a letter from S1 or we can replace a particular letter from S1 to get S2. So if we see the first example for this add one, so suppose if you have A and other you have AB. Okay, this is S1, S2. So you can either add B here to obtain the next like the set of characters from S2, or what you can do is if you have something like this AB comma A, so what you can do is you can delete this B and get A. So I have shown you like adding and deleting. So how you can to replace is, suppose you have BC and here you have BD, so you can replace this C with any character. The character can be itself also, so B and C can replace by BD. So this way these two S1 and S2 can be connected. Okay, so this is the three conditions that they have among the set of strings that you have, string 1, string 2, string 3, any two if you pick, and if you can perform any of these operation once, and if they are equal, then they are connected. Okay, this is what basically they are saying. Now let's see. So what their next statement is, the array word can be divided into one or more non-intersecting groups. Okay, the string belongs to a group if any one of the following is true. So basically saying, so using these three conditions, suppose we have few strings. Okay, S2, S3, S4 is here, then take S5 and S6, and using these three conditions we have connected these strings like this. Okay, let it be like this. Now it is saying can be divided into one or more in non-intersecting group. Okay, why it is in non-intersecting group? Let's see. The string belongs to a group if any of the following is true. It is connected to at least one other string of the group, or it is the only string present. So basically it is saying is either the string S2 for example is connected to other string, or it can be alone. Okay, so that forms a group. Now it is saying that the strings in the word should be grouped in such a manner that the string belonging to a group cannot be connected to a string present in another group. So suppose this S2 is belongs to this group. Okay, suppose this is a group 1. So this group 1, any of the string in group 1 should not be connected to any other groups. Okay, so this is basically, this should be an isolated group. Okay. This is an isolated group, this is an isolated group, like this. This is basically what I think. And you have to return an array where you have to mention two things. First is the total number of groups that get formed. So here you can see total number of groups that can be formed is 3. So the first one should be 3. And answer 1 is the size of the largest group. So if you see here, the group size is 1, here the group size is 2, and here the group size is 3. So basically you will have to return 3, 3. This is our answer. In short, if you see the summary of this whole thing is, you will be given the set of set of strings, and what you will have to do, you have to see which of the strings are connected. You will have to just connect them via like this, and then you have to find what is the number of components that are present and what is the size of the maximum component. That's it. This is basically the problem. So basically it's like this. You are given a graph, and in the graph you have to find the number of components or number of disconnected graphs, and second is what is the maximum amount of nodes that are connected. That's it. That's all you have to find out. So let's see an example here. So if you see this A, B, A, B, C, D. So A, when we pick up A, we check whether we can add it with B or not. So we can, because A we can replace it with B. So A and B are connected. Okay. Similarly, we'll see whether A and AB are connected or not. So this is, I'm just saying what is the approach. Okay, well, how we can get the answer. So A and AB can be connected because we'll add a character B. So A and AB are connected. A and CDE cannot be connected. Okay, so one thing also here to notice, if two strings s1 and s2 are given, we can perform either of this operation only once on this string s1. So we can either add or delete or replace. So basically when we add it, we get a string of length this s1 plus 2, we delete, we get a string of length this, and if we replace it, we keep it as s1. So if we take two strings, then s1 can be converted to s2 only if the length of s2 is less than equals to length of s1, okay, plus minus 1. Okay, that's it. So like basically if I do s1 minus 1 till s1 plus 1, so if the length of s2 is between these, okay, then only these two can be connected, otherwise not. So basically this is just observation, that's it. Now similarly B can be connected to A, which I have already seen. B can also be connected to AB, okay, because we can delete or we can add A here, and then B and AB can be connected. So like this, and then CDE will be totally loop. Okay, now this in this case, now how many components are there? So you can see there are basically two components. That's why here answer is 2. And then what is the size of maximum? That is 3, and that's why you have got here the same thing. Okay, now let's see the other example that we have. Here it is saying is you have A, B, A, B, C. So basically you can see A can be connected to A, B, and A can also be connected to A, B. Sorry, not A can be connected. A, B can be connected to A, B, C. So basically one group and 3 is the maximum. So that is why 1 over 3. Now let's see how we can approach this problem, and then we will see the solution for it. Okay, let me clear all the things first. Now let's see. So suppose this is the example that we have got. So what basically we can do is let's see like the brute force approach or how we can proceed with this. So suppose A is given. Okay, A is there. So what actions that we can perform on A? So first thing is we can either add, okay, or we can delete, or we can replace. Now let's see, when we are adding A and we are adding only characters, so there are 26 characters only, so we can run a for loop, and what we can do is, since we are only concerned with the set of characters and not the order of the characters, so in order to match it, what we can do is we can take each of these strings. See, this is what basically what I'm saying is the first approach that will come to mind. Okay, and how we can proceed with that, you will sort each of this string and will store him in a hash map or a hash set, so that you can get whether that particular string is present at, or not in a order of one time. Okay, so let's see. So suppose this is already sorted. So if it is not, let's sort it. Okay, let's assume that we have sorted it. Now let's add each character. So in A we can add a character. Okay, so in A, if you're going to add a character, it will be either B or A, C, A, D, and it will go up to AZ. So when we add a character to AZ, we'll just check, okay, the final character that we have, sorry, the final string that we have got, is it already present or not? If it is present, then those two strings are connected. Okay, that's it. Similarly we can do with AC, AD, and this way we can find out, okay, if AB is there and if something is added, then what is the other string that it is connected to. Okay, so that way we can connect. So A, we have added B, we can see, okay, AB is connected, so we'll connect A and AB. Okay, now what we can see, we can delete A, then we can see, okay, if you want to delete something from A, then we have to delete the A itself. Okay, suppose if A would have been a multiple string, like there were multiple characters in the string, so suppose there are 3, so we delete the first one first, then delete the second one, then delete the third one. So this we will have to do, and this can be done at most 26 times, because the length of the particular string will not exceed 26. Okay, so that all, this delete also will have to be done 26 times, and this also has to be done 26 times. Now replace. So what replace means is, replace here we don't have to do anything, because since we have already sorted the array, what we have to do, we have to just check whether the sorted array is present in the subset or not. So similarly what we can do, when we are suppose at A, okay, so let's see the basic algorithm that we are going to see is, when we are at A, we are going to see, okay, if we have added it, is there anyone that we can add? So we have added AB. So okay, AB is there, so we can add AB to it. Okay. Now what we are doing, we are going to pick up AB now, and we are going to see, okay, if we have AB and AB also, we can perform three actions, right? Add, delete, and replace. So while adding as well, we have to check, okay, what characters are there and what characters are not there, and based on that only we'll have to add. Suppose we cannot add a b a itself, right, because a is already present. So that way we have to add it. Suppose we have added c, and we have to check whether abc is there. No, it is not there. Then a b d is there or not. Like this we'll go and we'll see, okay, wow, there is no other which can be added. Okay, now we want to delete it, so let's delete first ab is there, let's delete b. So if B deleted, then A is there. So we have already connected A. Suppose A we delete, then do we have B? Yes, B is there. So we'll go and connect B here. Now from B we'll check. Okay, if we add A, so I've said you B A you have added because A is not there. But then again it is not sorted, so we'll have to sort it. So basically what I'm saying is, whenever you add, you get a string, and that string you will have to sort. Whenever you delete, you get a string, you have to sort to be on a safe side. So we can proceed with this, and then we can get a group. Similarly we can do for others as well. So once we have traveled all the strings and we have got all the values, we will get a component which is connected, and that way we can like tell, okay, these are the components that is connected, what are all the others that are not connected. Simple DFS algorithm, right? How to find the connected component. So that way you can get. But this is a bit what you can say, intensive task, because you have to add it, then you will have to sort it and all those things. So to overcome all these issues, we have tried to go through what you can say, bit masking. So what bit masking will say is, suppose you have a, so this a will be represented with 26, or when a particular integer has 32 bits, right? So will this a will be represented with the first one, then b, then c, then d. So for this a, the value will be 0 0 0 0 0 0 and 1. Okay, like all the zeros, 31 zeros. Okay, for b it will be 0 0 0 0 0 and dot 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 1 0. Okay, so if ab is there, then that will be represented by 1 1 and all the zeros. Okay, so this way. Now if we see our problem here, let me get it. Okay, let's see. So a, how we can represent it, will be 0 0 0 1. Okay, let's keep it. B will be 0 0 1 0. AB will be represented by 0 0 1 1, and C D E can be represented by, okay, we have to add another one here, 1 1 1 0 0. Okay, this is C, this is D, this is E. So what basically we'll have to do is, suppose we are at A. Okay, so we are at this, so we will have to do three operations, either add a character or remove a character, or like that. So what we can do is, suppose let's add a character. So while adding a character, how we can add a character? Suppose if we are adding b, then how we can represent that adding with this integer? That we will do by just flipping this particular bit, the 0 1. Okay, so what we can do is, we can do something like this, 0 0 0 1 1 when we add. Okay, so we'll check, okay, whether this particular string is already present or not. So it is there, so we'll store, once we have converted all these strings to this integer arrays, we'll store it in the map, or directly check whether this is present or not. So it is present, so we will get a, and we'll get ab. So you can see, like the in the previous one where we have to sort it and then check it, so that thing is not here. We can simply use bit masking to overcome that issue. Now we have to delete. So how we are going to delete is, we are going to unset a set bit. Okay, suppose if it is 1, we have to, we'll convert it to 0 and check whether it is, there is anything or not. Okay, and then when we need to replace it, so replace means what, we have to take a bit. Suppose we have this one. Okay, let's take for an example. So suppose here it is 1, here it is 1. So basically it is saying a b c d e f g h. So it is basically c and e. This is the string that is represented by the bit mask. Okay, now if you want to replace e with other character, suppose f, so what will happen, this will get converted to 0 and this will get converted to 1. So basically replacing means the one with bit set as 1 will be converted to 0, that will unset it, and the one with a 0 value will be set. So this will become basically CF. So this way we are going to use this what you can say replace with the bit masking one. Okay. Now I won't go through much of it. Let's see the code. I think you will better understand with that. Okay, so let me put it here. See, so what basically happened is you have created a hash map. So while we are creating hash map is when we are going to convert each word, suppose we have here, suppose we have got a word as AB. So what we are going to, we are initially setting the bit mask as 0. So suppose 0, 0, 0 we have set. Then for each character, suppose A, we are doing the CH minus A. So basically this will be 0 and we are appending it. So basically here we are going to do a XOR of A. So basically it will be 0, 0, 0, 1 for A. Okay. This append this. So for A character, this will be 0, 0, 0, 0, 1. Okay. So when we do OR, this is our bit mask after we have updated with A. Now when B comes, we'll shift 1 by A, so it will become 0, 0, 1, 0, and then it will do OR with this, so we'll get 0, 0, 1, 1. So this is our integer that we'll get. Now this integer we will store in the map. Okay, and why what we are doing is we are counting the number of times this particular integer can, because in the word array you can get suppose a b a b a b and all are a b, but what we have to do, we are just concerned with a b and the number of a b. Suppose for example here, see, you have a and a is connected to a b. So A is connected to AB again, other AB and AB. So these all can be merged, suppose, and then AB is connected with ABC. Okay, ABC. So all these will be connected to this again. So it's better we keep A, we keep AB, and we keep the count. Okay, this has come 3 times. Okay, and then we keep A, sorry, not here. A, B, C. So basically when counting the size of the array, we'll count, okay, this is 1, this is 3 times 4, this is 1, this is 5. So basically 5 is the size of this particular group. That is why we are keeping the count here. Okay. Now let me remove some of these. Let me remove all. Okay. So this is basically what we are doing. In the map, we are keeping it. And now we are going to get all the unique strings. So basically, as I have said, if we have multiple ABs, so we'll get a single AB for that. So unique strings we are getting out of this map, and for each of them we are traveling. Okay, for each of them we are doing a DFS. So it's like that you are given a unique number of nodes, and then you are doing DFS to find the components. Okay, now let's see the code here. So first suppose we have got A. Okay, for A we are starting, so we are going to DFS. This num is actually the value that we are getting from this unique string. So for this A, this num will be actually 1, 0, 0, 1. Okay, so 1 is there and then map is there. So we are checking whether that 1 is there or not. If it is not there, we are returning 0, and then we are getting the size of that particular, suppose A, so size will be 1, and then we are removing that particular bit mask from the array. Why we are removing it? Because we don't want to again travel it. So we are A here, and then we are what this thing, if you see, we are doing XOR, and then we are setting and unsetting that particular bit. So as I have told you that we are basically concerned with 3 type of operation. First is add. So for add, what we are going to do, for any bit that is 0, we are just flipping it to 1, and for delete, we are just flipping from 1 to 0. So here if you see, we are traveling for all the 26 bits because A to Z, and we are setting and unsetting that particular bit. So suppose for A we have 0, 0, 0, 1, and then we are setting a particular bit, suppose this A. Suppose we want to add a character B. So we'll go to B, we'll try to unset it. So if you are trying to add it, we'll convert that particular 0 to 1. So it will be something like this, and it will become AB. Okay, this is the method of addition. Whenever we switch from 0 to 1, we add. Okay, whenever we switch from 1 to 0, we delete. So here what we are doing, we are just flipping up that particular bit, and the delete and add is automatically taken care by in this single for loop itself. Okay, basically if you want to separate the add and delete one, so you will have to, what you have to do, you have to just put a condition if it is set. Okay, the bit is set, then you are flipping it, so this will become delete operation, and then you can again write a for loop from 0 to 26, and there you can put a condition. If it is unset, that is 0, then you set it, so that will become the condition for add. Okay, but both of them are combined together and formed in this loop itself. Okay, that is why this single loop doesn't have any other condition, and it is covered both the add as well as the delete. So once we have added any character, if you can see bit mask in this case, so we'll just go into DFS. So suppose if we have A and we have added a character, okay, B. So once we have added B, we'll go inside DFS and check, okay, whether that is there or not. If it is there, if it is not there, it will directly return. But if it is there, it means that AB is our value that is present, and we connect both of them. Okay, and we keep the size of AB. So size of AB is 1 only, and A is also 1. Now for this AB, we are going to add and delete. So okay, so if you see for this AB 00011 AB, if you want to delete, so what we'll do, we'll flip the 1 to 0. So adding, you won't get anything. So I'm showing why, like how to delete. So suppose we are at particular 0th bit, so we'll flip the 0 bit. So when we flip the 0 bit, what we'll get, 1 0, which is actually B, and then we'll check whether and then we'll go into DFS and we'll check whether the map contains the bitmask, that is B, or not. If yes, then we'll connect it. Okay, and similarly what we are going to do is here this operation is the replace one. Okay, so basically I think I have made you understand what is this delete and this add one works. Okay, now let's see how this replace works. So what we are going to replace, as I've said, we are taking the value of 1, converting it to 0, and then we are taking a 0 and converting it to 1. Basically this is what the flipping means. We are taking one and replacing with other. So if we have suppose AD, so you will have something like this, 1 0 0 1. Okay, A B C D, and we want to change it to AC. So what we'll do, we will convert it to 0 0 0 1 0 1. Okay, so what we are doing is this 1 we are converting to 0 and 0 we are converting to 1. So this is the very AC. So that is what you can see. We are first iterating through this 26 for loops, and each we are checking whether the value is 1 or not. Okay, this is the value when we are doing bitmask. This is the value which says, okay, the value is 1. And then when we pick up the value, we then again iterate over the other the same number and check which value is 1, sorry, which value is 0. Okay, so once we have checked the value 0, we then just replace those things, or we can put 1 as 0, then changing the bit from 1 to 0, and this is the from changing from 0 to 1, and then again we send to the DFS algorithm. That's it. So this is basically the algorithm for replace, and this is basically the algorithm for add plus delete. Okay, as I was also told you, like how you can separate those. If you want to separate those, you can just put an if condition in two for loops. You have to write two for loops. In each of the for loops, you have to write the condition that if it is initially the bit is 1 and you are converting it to 0, then that will become our delete operation. And if it is initially 0 and you are converting it to 1, then that will become our add condition. So basically both of them are merged here. So this way what it will do is this size we are going to add from the DFS. We are going to get the size and then we are going to return it. Okay, so here we have returned the size, and then we are going to check whether the max size is greater or not, and then we are each time we are doing group lookup like a typical component finding algorithm. Okay, so this way we will get the groups, and we also get the maximum size for each group, and that we can return. Okay, so this code will be available in the comment section. You can sorry, the description of the video. You can go ahead and check the code. So basically if you didn't understand this, try to go through the code, try to go to the video once. It's a basically easy one. We just have to make components, and the hard part was how do we check whether two strings are connected or not. So that was basically the hard part. Other part is easy, like finding the components and the size of each group. That's it. Okay, so that part is here, this bit masking part, and the other is this part checking off these and or connections. So basically these two are the add plus delete, and this is the replace algorithm. So I'll put this code in the description. You can go ahead and check it. I'm sure that you will definitely understand this. If not, just mention in the comments. I'll try to make the things as clear as possible. Okay, thank you. So I hope you would have liked this video. So if you do, please like the video, comments, and subscribe to the channel. Okay. Thank you.